Welcome to Enhance Impact. Today, we are cleaning Airbnb data. Thank you for joining today. If you like the video, give me a thumbs up and subscribe. Without further ado, let's begin. The data that we're working with comes from this website. It's inside Airbnb. They scrape the data from Airbnb's website and provide it in a nice format, in CSV formats for different cities around the world. Today, we'll be working with Albany, New York data, the listings.csv data specifically. This is what that data set looks like. Has ID, name, host name, and so forth. For more information about these different fields, you can go to the data dictionary that they have listed at the site, and this is what that data dictionary looks like. It provides the field name, the data type, and a description of the field. Today, we'll do our data cleaning inside of the Jupyter Notebook. The general guidelines or steps for cleaning data is to drop duplicate data, remove irrelevant fields and rows, fix any structural errors. In this situation, we'll have some data type mismatch that we need to repair, handling missing data by either dropping features or filling in that missing data with the mean, median, or some other method. First, look at the data. Let's first start off by importing our main packages, which are NumPy as MP and import pandas as PD. I like to include this pd.set option because it allows us to be able to see all of the columns, because we don't have 500 columns, but up to 500 columns without any truncation. Here I'm reading in my data set, so let's load our packages, read in the data set. This is the file path where my data is actually located. Notice that I have forward slashes between the different folders, which is important. Otherwise, you get some sort of error, but you can get around it. But it's just easier when you have a forward slash there. I want to take a look at the data, but instead of going df.head to see the first 5 rows, which is this, our first row is going to begin with the number 0. So 0, 1, 2, 3, 4. So this is first 5 rows. Or df.tail to see the last 5 rows. I like to use sample instead. And I like to use sample because sometimes when data comes in, it may be already sorted in some sort of way that can impact how what your first view of that data actually looks like. So I'm going to go df.sample and tell that I want 5 rows. So df.sample 5. Here I have row number 32, 33, 154, 375, row 4, index at row 4. And the data, let's look at it. ID is the scrape ID received at the time that the data was scraped. Name has information related to if it's a rental unit, if it's a home, how many bedrooms it has, if it has a star rating or what the star rating is. The host ID is like a numeric identification for the person that owns the listing. This person's name, the host name is usually the first name. Here we have Michael and Florida, or 2 people. The neighborhood group, that seems like we have a lot missing for neighborhood group. Neighborhood, they tell you the neighborhood, latitude and longitude for plotting the data geographically or mapping it. Room type, whether it's a private room, if it's an entire home or apartment. The price per night. Here, this private room is listed at $60 per night, and the person must book for at least 4 nights before it can be rented to them. So that's the minimum nights. Number of reviews so far over the lifetime of this unit at the time of the scraping was 19 reviews total for that listing. The last time it was viewed was in 2020, and the average number of reviews per month was 0.28. This host, these 2 people, I think their names were, Michael and Florida. They have 6 units that are listed on Airbnb. So those are the number listed, or 6 listings on Airbnb. Availability, they have 249 days of availability. That means that's 249 days left. That's different. That difference depends upon the unit. This is listed at only 21 days remaining. So it seems like that might have more bookings. So they don't have as many days available for renting. Number of reviews in the last 12 months, 0 for this one, 1 for this one, 66 here. I see that license has a lot of missing value for license as well. For us to check the number of rows, and the number of columns, we can go df.shape. That provides 391 rows or records and 18 columns. I often say it like our first step is to make sure that we can drop any duplicates. So we want to check for duplicates. The way that I check for duplicates is I just count how many rows I have in the original data frame and subtract it from the rows that I have in the data frame when duplicates have been removed. So here I got length of the data frame to give me the number of rows that are in the data frame minus the length of the data frame when we drop duplicates from that data frame. And here we get 0 because they're the same. There are no duplicates, and so we get 0. To get some more information about the data set, we just df.info. And as we noticed before, we have 391 records or rows, and we have a total of 18 columns. The df.info also provides information related to the names of the features, as well as the data types for those features. And the middle column tells how complete the feature is. We have 391 records. ID is complete at 391 non-empty or non-missing or non-null columns. So it's complete at 391. We can see a neighborhood group is completely missing. They have 0 non-empty or 0 non-null entries for neighborhood group. All right, I also like to calculate the percentage of missing values. So we do calculate that. The way I do that is I take what's missing in the data frame and count it up and divide it by the total number of rows. And I do that because I'm not just interested in how many is missing. I want to know what proportion. And I also like to get percentages, so I multiply by 100 for that. And I don't want a lot of trailing digits after the decimal point, so I like to round it to do 2 decimal places. If we do it this way, we get, oh, this neighborhood group, as we expect, is 100% missing. If you have a long list of features, here we only have 18 fields, but sometimes you have data sets with a lot more features. So when you're working with large data sets, I like to sort the values so that I can see the things that are missing on top. So I don't need to see if I actually have 0. I really want to know, okay, I have the 100% is 11.76%. So I do this by sorting the values and indicating that I want ascending to be equal to false. So we want top down as opposed to bottom up. So here. So now we can see, oh, the ones that have the most amount of missing is at top, and the ones that have the least amount of missing, which is at 0% here, is at the bottom. So I can attend to what's missing first. So license and neighborhood group, these are 2 columns that they're 100% missing. They're not going to add any value, so we're going to drop those columns. I do a lot of copy and paste because it's, fewer mistakes that way. So I wanted to basically ensure that the names are correct. So here, okay. Okay, so we have df.drop. And when you drop it, you have to tell them what axis you're dropping from. So license and neighborhood group, we're going to drop it from the column. So if we're dropping it from the column, that's axis is equal to 1. If you were dropping rows, you would do axis is equal to 0. Every time you do any work on the data, just go back and take a look at it to make sure it's correct. So once we finish with this, dropping these columns, I want to be able to see that represented in the info field, and also here. We could look at it here too, but if I go to the info field, you remember we started with 18 columns. If I drop it, I should be down to 16. So here, now, you have to assign it back to the original data frame. So now what we have here is 16 columns total. 16 columns. When you look at reviews per month, And last review, we noticed that it's the exact same, 11.76%. So those are likely to be trending together. So if you have reviews per month, if it's missing, then the last review appears to also be missing. So if we want to take a look at that, so if we're looking at last review, I want to know where it's missing and want to get a sample of that so I can take a look at it. So here this is filter the data frame so that the last view is missing. And I want a sample of like 5. Let's go with a sample of 6 records instead of 5. So when I look at that, you notice that 2 things were missing. Last review was missing, and reviews per month were also missing. And they're missing together. Okay. So last review and reviews per month is missing. If you look at the number of reviews, that's also an indication of something, because wherever we have a last review missing and reviews per month being missing, I'm noticing also that when we look at the number of reviews, that's also missing. So this indicates, hey, there weren't any reviews. So if there aren't any reviews, then there won't be any reviews per month. And apparently it says there has not been a last review. So for a situation to have no reviews and no reviews per month, and there is no last review, it's a good chance that these are likely new listings. These are likely new listings. What else is very important to take note of is last review. We got to work on that field, because last review, if you look at it from the very start, last review is actually a date column. Remember from at the start, the top? Last review is a date column. So there's no date for the last review. Okay, so that also tells you something there. Those are likely brand new units. Okay, the thing about data cleaning is almost like you're doing some exploratory data analysis with the data cleaning. That's part of it. That's what data wrangling is what it is. Okay, so let's take a look at some other things. I wanted us to take a look at a data type mismatch. So we've already looked at the error, the percentage of missing is here, and recognize that there's a pattern there. Okay, that if one is missing, the other is missing, and it's probably missing because those are likely new listings. Let's take a look again for dropping irrelevant data types. We did that, and also look for fixing structural errors. For example, data type mismatch. In here, I saw a data type mismatch, and it's showing up here in ID. You'll notice that the data type is a float. An ID is very much like you would think of a name. Like the host ID is like a name. You don't want to add or subtract with that, or do any computation with an ID value. So the ID should be not in a decimal format. It shouldn't be in an integer format as we see in the host ID down here. So these two, we need to correct the data types for those. Instead of having a numeric data type, they need to be of an object or string data type. So for host ID and ID. Also, we talked about last review. In last review, it's supposed to be a date field. It's not a string field. It's not a numeric field like a float or decimal or integer. It's supposed to be a date time format. Here you'll notice this in the object format, as though it reads as a name as opposed to a date. We also have to fix the last review. So what you see here, there are data type mismatches for ID, host ID, and last review. We're going to work on converting the data types for ID and host ID to object data type. We use double brackets for this for ID and host ID. We can convert it to a string data type. You can use O for object or object as well, but I just use string for str for string. And we're going to take a look at our info once again once we do that. And now when we come and take a look at the information, we have ID is now an object data type, and host ID is also an object and no longer in a numeric format. Before viewing, I want to correct this data type mismatch. So for our data type mismatch, oh, this is why I want to do my sample. I almost forgot. Let's go back. Okay, so let's take a look at the sample of 3 records because I want to know when I do the conversion of the date time for the last review field, I want to know what format the data actually has to be in because I need that to convert the data type. So when we come down here to last review, we see this is the format where it's in month, day, and year format. So for our conversion for our data type, we're going to have our data frame be df.last review. It's going to equal to pd.to underscore date time. This is the field we want to change. And we want the format to be in the format where we see the day, or we want the month first, so the month. We want our day / and then we want our 4-digit year, which is uppercase Y. And so now our last review is in our date time format. Okay. Now we're at a place where we're looking at how to replace those missing values, and that's part of our general data cleaning steps, replacing missing values. In this situation was 0. The reason why we're going to replace with 0 for, as we saw above, let's take a look. I think we were right. Yeah, right here. We notice that when you look at your number of reviews and reviews per month are related. If you have never had any reviews, you have 0 reviews, then you're going to have 0 reviews per month. And so that's what we're going to recalculate. So whenever we have our, we're going to fill reviews per month when it's missing to 0. So here, we're going to fill the missing value with 0. And I want to take a look now at the data frame when the last review is missing, because remember when we had missing last review, we had reviews per month also being missing. So we can see what that looks like now. We have df, we have last review, okay, so now let's take a look at it. 2 things that happen. Here we had reviews per month is now in 0 format, and the last review is it's missing still, but now it tells you there's a T there to let you know that's in time data set. It's a date time format. Okay, so let's take a look. Calculate the percentage of missing values and sort now. So we're going to do that again. Well, I've already done it once. I don't like to, if you can reuse the code, just go ahead and reuse it. So calculate the percentage of missing values and sort. So let's take a look at it now. We're going to go back, grab our code where we're looking for our missing values, and we're going to sort those right here. This is our code. So here, take it, come all the way down with it. I copied it, paste it. And see, now all you see is that last review is missing 11.76%. Because it's a date field, I don't feel the need to actually create a date for it at this time. I think I'll wait for that for exploratory data analysis if I decide to do it. And so that we're going to leave that last review date field empty because we don't have any reviews. And so it doesn't really make much sense to add a review date. So I'll just leave that as is. What it does speak to is that if you have a last review of 11.76%, it may speak that, almost like 89, 88% of the fields are not new. And so you only have like about 12% or brand new listings at the time of that the data was scraped. I noticed that there was some other information that was very interesting to take a look at that is not in the fields. It's actually in one field. And so in that name field, there's a lot of good information. Things related to the number of bedrooms, if it's a shared bedroom or a shared bathroom, how many baths there are there, how many beds are there, and what the rating actually is. And so I wanted to break those fields out. And this is here I'm working with regular expressions. You can go to the Python. I'll actually leave a link to the resource for working with regular expressions in the link below, along with a few other resources to inside Airbnb and others. So here, this function extracts values, detects and a pattern, do a pattern search, and will do a match. If the match exists, then it provides the number for number of bathrooms, number of bedrooms, shared bathrooms, number of stars. And if it doesn't, then it just says that there's nothing there or none, or puts an empty value, so a null value. So what the bedroom pattern looks like is this compile is used to make the string into more of an object format. The R allows for not the backslash not be an escape. It's just looked at as just a literal string. So what this does here is it says that, hey, if you return the number that has a space in front of the word bedroom, it could be one space, multiple spaces, because I see a star here. And so that's what happens with the bedroom pattern. If you see bedroom and there's a number in front of it, return that number if it exists. For bathroom, same thing, except it allows for having decimals. So instead of like one bathroom, it could be 1.5 bathrooms, 1.52 bathrooms. And the same thing for bedroom pattern, and the same thing for the shared bathroom as well. And number of stars. So number of stars, we see we have the D plus and the dot and the D plus. The dot is just the indication of a decimal point. So 2 or 4.7 or 4.75 or 4.76. The plus allows for additional numbers on the end of the decimal point, tenths, hundredths, whatever. So what happens is this function is applied with a lambda expression to extract the values that are within the bedroom pattern, and it basically creates a decimal value for it. So if you have this is essentially the format that will come up. So you'll have number of bedrooms, and it'll tell you what the number of bedrooms in numeric form is. It's a decimal. And same thing for shared bathrooms, number of stars, number of beds, and so forth. So I'm going to run this field here and take a look at the data frame. So df.sample, let's do a sample of 3. So we can take a look at those 3 rows. And what happens whenever you add any additional fields to a column or any feature engineering, it usually occurs on the right end, or basically the end of the data frame. So these new fields are here. Number of bedrooms, they tell you 3.0, 1.0. Number of bathrooms, 1.0. We have some missingness for number of bathrooms. Number of bedrooms, missingness I see for shared bathrooms right away. And so if we want to calculate again, well, how much do we have missing? Just go back and reuse the code. So we're going to go back. This is the code that we had before. We're okay with having a missing review date because we don't have a last review date. It's just not there. And so reuse the code to get the percentage of missingness. And so now we said, oh, well, 82% for shared bathrooms is missing. And we have number of bathrooms is missing about 24% here. And this is okay, number of stars and last review And you got number of bedrooms. You see that's missing 3% here. That's not bad for 3%. So when I look at this and it says shared bathroom at 82%, you have to start to think about, well, why do I have that much missing for shared bathroom? A lot of places may not have a shared bathroom. What you may see is if you have a bathroom and your number of bathrooms, there may be an interaction here. So like if you have a number of bathrooms, you might not have a shared bathroom. If you have 2 bathrooms, you might not have a shared bathroom. There's 2 separate bathrooms. So let's take a look at that. Before I actually had some more information on that. So I want to create a new field below, and let's just take a look at the data. View the relationship between shared bathrooms and this number of bathrooms. So what I'll do here is just look for the situation where the shared bathroom is missing. Shared underscore bath. And get a sample. Let's do 10 of them. So here, what we're looking for, come all the way down here. I want the situation where the number of the shared bathroom is absolutely completely missing. So here I have shared bathroom is completely missing. And when it's missing, number of bathrooms is present. See? Now, if we go on the reverse of that and say, hey, what if you can tell me if we have a number of bathrooms missing? So if I go here and say, hey, number of bathroom, what's happening with that 24% or almost 25%, the quarter of number of bathrooms being missing? So we look and we say, okay, what if we say, replace it and say, hey, I have missing bathrooms. What kind of relationship is that with the shared bathrooms? And what you see here is this. Oh, when we don't have any bathroom listed, I'm seeing shared bathrooms. See, shared. This is a situation where they're both missing. And this is a situation where we have different scenarios. Either shared bathroom is missing and the number of bathrooms is not missing. So if shared bathrooms is missing and number of bathrooms is not missing, we'll put a 0 for shared bathrooms. I developed 3 rules to tackle this situation. One situation where both bathrooms and shared bathrooms are missing. And what we're going to do is impute the mean for the number of bathrooms. The reason why we're choosing to use the average number of bathrooms is there are typically more bathrooms than shared bathrooms. And so when they're both missing, we're just going to replace the missing value for number of bathrooms with the average number of bathrooms and put a 0 for the shared bathrooms. So this is what this code does. So here it says number of bathrooms, apply the rounded mean, which is here. We're taking the average df number of bathrooms dot mean, round it, and we're going to replace that anytime we have a missing number is in A for number of bathrooms and is in A for number of shared bathrooms. If there's not missing this, then we just leave the number of bathrooms value as is. Shared bathrooms, when there is a 0 for shared, we put a 0 in for shared bathrooms when the number of bathrooms is missing and when the number of shared bathrooms is missing. The second situation is when bathrooms are missing and there's a value for shared bathrooms. In that situation, we want to keep the value for the shared bathrooms. So for a number of bathrooms, make it a 0, and if it's missing, and if the shared bathroom is not missing, then let's make that let's put a value in for that. And finally, the third scenario is we will replace shared missing values with 0 when there is a value for the number of bathrooms. So if you have a situation where, hey, we have a value for number of bathrooms, and we also have a situation where shared bathrooms is missing, just go ahead and make shared bathroom 0. So this is what this code does. Now let's calculate the percentage of missing after applying this code here. So let's apply this code. And we'll take a look at what our percentages of missingness are now. And what we see now is we no longer have any missing values for the shared bathroom or for the number of bathrooms. We still need to take care of the number of bedrooms having about 3% missing. And for that, we're just going to fill that with the average. So we can do that now. I like to copy and paste over our number of bedrooms. Our preferences, just go ahead and copy. Fill missingness with the average. Mean. Okay. And we go ahead and take a look again at what happens after we do that. And so now we can see that the number of bedrooms is no longer missing. So the last thing to take a look at, we know we're going to keep the last review as is. I've decided here not to bother the last review, this date for an unknown date for listings that are probably relatively new. So here we're going that 11.76%, we're going to leave that missing. The number of stars rating, well, if there isn't a star, we can't really force a star to be there, but it will be interesting to see what kind of impact the number of reviews has on the number of stars. So you have to have some sort of review in order to get a star. So let's take a look at the situation where we don't have any stars. What does that data frame look like when we don't have any stars? So this is where it filters DF number of stars is null. When that's null, what does that look like? What are we seeing for number of reviews? So when I look at the number of reviews, when we don't have any stars, let's go over and look and see where our stars are. See, no stars. When we don't have any stars, the number of reviews, I see 1, 2, 0 reviews, only 1 review over the lifetime of the listing as at the time of the scraping, 0 here. Let's take a look at the distribution for the number of reviews when there are no stars. So we take our no stars and number of reviews. Number of reviews. Let's see if I got that. Here we go. Number of reviews. Let's copy it and paste it. Why not? Okay, so number of reviews dot describe. And so what we see is that the average number of reviews is 0.625, less than 1. Less than 1. The median number of reviews is 0. Max number of reviews is 2. So at best, you have 2 reviews when you have no stars. So let's take a look at what happens when we say it has stars. How do the number of reviews compare when we actually have stars? So this one is, I'll put a tilde in front of the DF number of stars. Just basically means the opposite of not null, which is actually has a value. So let's take a look at what that sample of a data frame looks like. When there are stars, here are the number of stars, the star rating 4.8, 4.98, 4.84. What does the number of reviews look like? Number of reviews over the lifetime of the listing, 308, 130, 4, 338, 43. So let's take a look now at the situation where when we do have stars, what does the distribution number of reviews look like? So here, I like to just keep the codes. This is has stars instead of no stars. So has stars, that column for number of ratings, what does the distribution look like? It's a totally different thing. At minimum, there are at least three. There are at least 3 reviews. and we're saying the median of 27, average of 64, max of 721 reviews. So here, this leaves room for us to actually do some feature engineering, because we may be interested, we may not be able to get access to information related to the stars that are missing, but what we can do is add a new field, and in the new field, we can create has a star rating. So df has underscore star underscore rating, np.where the number of reviews is greater than 2. If the number of reviews is bigger than 2, then we'll say true. In other words, it has a rating, and false otherwise. And so this is what we'll do here. And so our new column is here, has star rating. Okay. And if we wanted to just to keep checking and say, hey, well, I see this the situation where we always have a rating here. Can we find it where we don't have a rating? So, and see if this actually took, if we still got the true and false to be the same. So we should have false when we don't have a rating. I love the sample because the sample, it allows you to do just that, get a sample, and we can also increase the number of our sample. We can do a filter as well, but it's just easy, the code's there. So let's take a look. Go all the way down. And here we have a situation where number of stars is none, then we have a false. Where we have a rating, we see trues. And when we don't have a star rating, we're seeing false. Okay, so that's pretty much it. All right, so this is it for the data cleaning of this Airbnb data. Thank you for watching the video. I hope that you enjoyed this data cleaning activity. We really dug deep today with our data wrangling. Stay tuned for our next video on modularizing this code for data cleaning. And so this, we can do almost cleaning in an instant. And so, yeah, until next time, peace. And remember to give me a thumbs up, like if you like the video. Yeah, and be well. Thanks.